For nearly 50 years, a small, lonely craft has been drifting through the silent dark, Voyager 1. It is the furthest any human-made object has ever traveled, a tiny messenger carrying a golden record and the echoes of a world it left behind in 1977. In 2012, Voyager did something no other machine had ever done. It crossed the heliopause, the invisible boundary where the solar wind from our sun finally dies out. It officially entered interstellar space. For many, this felt like the edge. We had finally left home and stepped into the deep ocean of the galaxy. But as Voyager drifts further away, at 38,000 miles per hour, it is heading toward a much more terrifying realization. No matter how long it travels, even if it drifts for billions of years, it will never, ever reach the edge of the universe. You see, the universe doesn't end with a physical wall. It doesn't have a giant sign that says, "The end." Instead, the universe ends with our eyes. We live inside a massive, invisible sphere called the Observable Universe. It is a bubble of light, 93 billion light-years across, with Earth exactly in the center. This isn't because we're special, it's because of the speed of light. Since the Big Bang happened 13.8 billion years ago, light has only had a limited amount of time to reach us. Anything beyond that bubble, it is effectively non-existent to our telescopes. Imagine you're standing in a dark forest at night with a flashlight. You can see the trees 10 feet away, but does the forest end where your light stops? No, the forest continues into the darkness, perhaps forever. This is the cosmic trap. We are trapped inside a bubble of information, watching a movie that started billions of years ago. But what happens if we try to look through the screen? What if there's something on the other side of that light that is trying to get in? If you want to find out what lies beyond the last photon we can see, make sure to hit that subscribe button. We are going to the very end of reality, here on Exoplanet X. To understand the edge of our world, you have to understand a fundamental secret of the cosmos. Looking far into space is exactly the same as looking back in time. When you look at the moon, you see it as it was 1.3 seconds ago. When you look at distant stars, you are seeing light that began its journey while dinosaurs still walked the Earth. But if we keep looking further, beyond the stars, beyond the first galaxies, we eventually hit a wall made of pure ancient light. We call it the cosmic microwave background, or the CMB. This is the afterglow of the Big Bang. For the first 380,000 years, the universe was a screaming, opaque soup of hot plasma. It was so dense that light couldn't travel. It was trapped, bouncing around like a ball in a crowded room. But then, in a single moment of cosmic cooling, the fog cleared. The first photons were set free, and they had been traveling through the dark for 13.8 billion years. This is our true horizon. Beyond this wall of light, there is nothing. At least nothing our eyes can ever see. It is a curtain pulled across the stage of the universe. No matter how powerful the James Webb telescope becomes, it can never see through this fire. We are looking at the very birth of transparency itself. But here is where it gets unsettling. When we map this wall, it is almost perfectly smooth. It's too perfect. Some scientists believe that the tiny ripples we see in this static aren't just random noise. They might be bruises, marks left behind by other universes bumping into ours from the outside. If the CMB is a wall, then what is the foundation it's built on? And if we could somehow step through this fire, what kind of reality would we find on the other side? A place where time doesn't exist, or a place where our universe is just one of many? If our observable universe is just a bubble of light, the question remains, how big is the rest of the ocean? If you could teleport instantly to the very edge of our horizon, what would you see? The short answer? More stars,
more galaxies. To an observer at our edge, Earth would be the one sitting at the limit of their observable bubble. But this doesn't mean the universe is infinite. It just means it's much, much larger than we can imagine. Some models suggest the entire universe is at least 250 times larger than the part we can see. Imagine our 93 billion light-year bubble is just a single light bulb in a massive skyscraper. Others, however, believe the universe is truly infinite, an endless sea of matter that never, ever stops. But there's a third possibility, one that sounds like a video game, the toroidal universe. Think of the game Pac-Man. If you move off the right side of the screen, you instantly appear on the left. In this model, space is curved. If you flew a spaceship in a straight line for long enough, you wouldn't hit a wall. You would eventually see the back of your own head. You would end up exactly where you started. If the room is this big, or even infinite, it brings us to a haunting paradox. In an infinite universe, every possible arrangement of atoms must repeat. Somewhere out there, beyond our horizon, there could be another bubble exactly like ours, another Earth, another you watching this exact same video. Is the edge just a loop? Or is the universe so vast that we are effectively alone in our own tiny pocket of reality? We may never know, because the space between these bubbles is expanding faster than the speed of light. Even if we had a ship that could travel at the ultimate speed, we are losing parts of the universe every single second. The room isn't just big, it's growing.
If our universe is a bubble, then what is it floating in? To answer this, we have to look at the theory of eternal inflation. Imagine a vast, boiling ocean of energy. In this ocean, space is expanding so fast that it's almost impossible to comprehend. But in certain spots, the expansion slows down. A pocket forms, a bubble. That bubble is our entire universe. Everything you have ever known, every star and every galaxy is contained within this one tiny drop in a cosmic sea. But if we are just one bubble, then the edge of the universe takes on a whole new meaning. It's no longer a wall of light or a loop of space. It is a border, a skin, and on the other side of that skin, there are other bubbles, other universes. Some might have the same laws of physics as ours. Others might be completely alien, places where gravity works backward or where time flows in circles. Most of these universes are drifting apart, forever out of reach, but sometimes they collide. Remember that wall of light we talked about earlier, the CMB? Astronomers have found a strange cold spot in that map, a giant empty void that defies explanation. Some believe this isn't just a random gap. They believe it is a bruise from a collision, a permanent scar left behind when another universe slammed into ours at the very beginning of time. If this is true, then the edge isn't where things end, it's where things meet. We aren't living in a lonely void. We are part of a crowded, violent, and beautiful multiverse. But as we look at these massive scales, we have to face the ultimate, most disturbing theory of all. What if we aren't the ones looking at the bubbles? What if we are the ones inside the simulation?
If we cannot see past the wall of light, and if the universe might be an infinite loop, we have to ask the ultimate question. What is the nature of the room itself? Some of the world's most brilliant minds, including Stephen Hawking, proposed something that sounds like science fiction, the holographic principle. This theory suggests that the edge of the universe isn't a place at all. It's a boundary where all the information of our 3D world is stored. Imagine a 2D credit card that holds a 3D hologram. In this view, our entire reality, the stars, the galaxies, and even you, might just be a 3D projection of data encoded on a flat surface at the very edge of the cosmos. If this is true, the edge is the only place that is actually real. Everything else is just a projection. But there is another possibility,
one that is even more organic. When we look at the largest structures in the universe, the cosmic web, we see something hauntingly familiar. The way galaxies cluster together looks exactly like the neural network of a human brain. Could it be that we aren't looking at an empty void, but a living system? What if the expansion of the universe is simply the growth of a cosmic organism? If so, the edge is simply the limit of this organism's current reach, a horizon that is constantly shifting as the universe learns and evolves. Voyager 1 is still out there, drifting into the silence. It will never hit a wall. It will never see the end, because the universe isn't a box we are trapped in. It is a fractal of infinite complexity. Every time we reach a new edge, the edge of our atmosphere, the edge of our solar system, or the edge of our light, we find that there is always something more. The edge is not a destination. It is a reminder. It reminds us that no matter how much we map, the mystery will always be larger than the map maker. We are a way for the cosmos to know itself, and our journey into the dark has only just begun. Thank you for traveling to the edge of reality with us. If this journey changed the way you look at the stars, leave a comment below. What do you think is waiting for us on the other side? This is Exoplanet X signing off from the final frontier.